to talk about the shape of a polynomial, because the shape of a polynomial function is going to depend on its degree. So if we take a look at the first picture, our first picture is a quadratic function, which means it's a degree of 2. Quadratic is a degree of 2, so it has like an x squared. And a quadratic function, since it has a degree of 2, can have up to 2 roots. So if I take this and just watch, because you don't have this line in front of you. So if I take this line, and this is like my x-axis, the quadratic function could be tangent to the x-axis and bounce, which would give it a single root, but it would have a multiplicity of 2. Or if I move it up, it would cross the x-axis 2 times. So a quadratic function can have up to 2 roots. If I took it and I moved this, and I moved the line, let me just lock this other piece in place so it doesn't move on me. If I take this line and I move it down here, it touches 0 times. And we're going to see that that will eventually mean there are imaginary solutions, or there are no real roots. So now if we take a look at this graph, maximum and minimum, there is one max or min. A maximum or a minimum is like a turning point. So now if we move on to our second graph, this is a picture of a cubic function. Cubic function is degree 3, which means it can have up to 3 solutions, or up to 3 x-intercepts or zeros. So if I take my line and I move it over here, it would have 1 solution. If I keep moving up here, it would have a single root and a double root, or a multiplicity of 2, where it bounced. So it would only have 2 solutions. And then if I keep moving it up even further, it would have 3 solutions. And if we take a look at our maximum and minimums, there's 1 max and 1 min for a total of 2. Now if we take a look at our quartic function, that's a degree 4. So that means we can have up to 4 solutions. So let's take a look. I can have 1 solution. I can have 2 solutions. And remember, my solutions are the same thing as my x-intercepts. So in this case, it's where it's crossing the line. So if I go back here, it touched it once. So that would be 1 x-intercept. If I move it up here, it would touch it twice. If I keep going, this would be 3 times or 4 times. So these are all different possibilities for a quartic polynomial. It can have up to 4 real roots, or real x-intercepts. And if we take a look at our max and mins, or our turning points, this time we have 3 of them. Lastly, on the right, we have a quintic. That is degree 5, which means it can have up to 5 zeros, or up to 5 x-intercepts. So here would be 1, 2, this would be 4, this would also be 4. So it's just going to depend on what the picture looks like. But we know that based on our degree, there can be up to that many x-intercepts. And if we take a look at this, 1, 2, 3, 4 turning points, or 4 maximum and minimums. So the word local extrema is going to come up. It came up in our target earlier. Local extrema is just a maximum or a minimum, a turning point in its neighborhood. It's called a local extrema because it's in that general area. It's not going to be the maximum of the entire polynomial function, but in its general location, it's considered a maximum or a minimum. If we go back up here and we take a look, for example, at this quartic function, there are 2 local minimums. Right here would be a local minimum because in its area, it's the lowest point. And then over here would also be a local minimum because in its area, or in its neighborhood, it's the lowest point. So the one on the left, even though it's not the lowest point in the entire function, we still call it a local minimum. And if we take a look at the relationship between the degree and the max and the mins, you should notice that your maximum and minimums is always going to be one less than your degree. So if I have a cubic function is degree 3, I can have up to 2 max and mins, or up to 2 local extrema. Just like I can have up to 3 zeros, or up to 3 x-intercepts. So that's our shapes of polynomials, how they relate to the degree, which is also related to our zeros or x-intercepts, as well as the local extrema.